Okay, hello. It's good evening in my part of the world. I'm just doing a quick run through for this Year 10 IGCSE Term 2 test paper. Now, this is really useful for students doing IGCSE revision because this test paper covers the first three topics which you studied in Year 10 probably. The first three topics are forces, electricity, and waves. Okay, so these are the three biggest topics in IGCSE. So if you need to revise these, this is a really good test paper to use if you're doing physics IGCSE. Okay, so this is for physics. Doing full physics IGCSE. Okay, because this only covers the content in triple science. It's not going to be content that comes in double science. So if you're doing double science, this is not the paper for you. Okay, so this is triple content only. All right, so what do we cover in this test? It's only 30 marks. It's conservation of momentum. So that's from forces. Principle of moments, also from forces. Static electricity phenomena, okay, and sound. So these are all the bits of the first three topics which do not get tested in paper 1. So that's why we called it a paper 2 practice. Okay, forces, electricity, and waves. Okay, so if you're revising for your IGCSE this year, even though it's Year 10, it's actually perfect for Year 11 students. Okay, IGCSE, EdXL, physics, and let's go straight into it. The first question wants you to look at the units of momentum. So the question is about momentum. Which is the correct unit for momentum? Okay, so to be able to work it out, you need to know that momentum is mass times velocity. And if you know that the equation is mass times velocity, you know that you've got kilograms for mass and velocity is meters per second. So the units of the left-hand side of the equation must be also the same on the right-hand side of the equation. So the answer is D, kilograms meters per second, is the correct unit for momentum. Okay, none of the others have it written quite correctly. Okay, so once you know the equation, you can actually work out the units. It's very, very useful skill to have. So that's 1 mark. The next question, it shows a diagram. It shows an object before and after it splits and goes off in opposite directions. So we call this an explosion. Yeah. So the object breaks into 2 parts, P and Q. So here's P and here's Q. So you can see Q goes to the right, and we know its velocity, and P goes to the left, and we have to work out its velocity in a moment. So initially, so before the explosion, the full weight of the mass was stationary. It wasn't moving. Okay, and it's 4.8 kilograms. So it's just standing still. So the momentum before was 0. It was just stationary. And so how can it produce motion? Well, it's an explosion. That means it splits apart according to the masses. 2.9 kilograms goes backwards, if you like, to the left, and 1.9 kilograms goes forward to the right. It doesn't split in equal halves. So after we got 2 bits of motion, And basically what you know is the motion to the right must balance the motion to the left, or the magnitudes must be equal. The size of the momentum to the right must equal the size of the momentum to the left, and because momentum is a vector quantity, yeah, that means the direction will do the balancing, and that's why I put the arrows on it. So first of all, you need to know what is meant by the principle of conservation of momentum. And the principle of conservation of momentum is that before the event, in this case it's a separation of two objects in opposite directions, the total momentum before it separates must be equal to the total momentum after. Okay? Now the total momentum before was 0, yeah? And we always say that this is in the absence of the other external forces, yeah? So if there are other external forces, then of course the physics becomes more complicated. In this case, the stationary object just splits into two, yeah? And goes into two opposite directions, okay? An example could be a bullet and the rifle. The bullet goes one way, the rifle recoils in the opposite direction. Initially, the rifle and the bullet were stationary. Okay, so that's an example of this kind of question in physics. All right, so how do we do it mathematically? So, mathematically, this is done by calculating the magnitude of the velocity. They want us to calculate the magnitude of the velocity v, which is the only unknown. So we know the mass of p, we know the mass of q, and we know the velocity of q. The only thing we don't know is the velocity of p. Now we know the total momentum before must be equal to the total momentum after, yeah, and before it was 0, yeah. So how can it have velocity? Well, if they're equal, one must be positive and one must be negative to add up to 0, yeah. So you could say that the momentum to the left must equal the momentum to the right, and right could be counted as positive and left can be counted as negative, a bit like in maths on the graph. If we go to the right of the origin, it's positive. If we go to the left of the graph, it will be negative. That's the method. So you could keep it as simple as momentum to the left must equal momentum to the right, and basically it's the same thing conceptually. So we know the mass of P is 2.9, yeah? So the mass of P is given here. And I don't know the velocity of P, so I've put V as velocity of P, yeah? We know the mass of Q is 1.9. So let's just do that one again. So the velocity of Q is 1.9 kilograms. So that goes in here. And we know the velocity of Q also goes in there. Okay, so we put these values in. So the only unknown is velocity of P. So now it's just a matter of algebra. Make Vp the subject of the equation. The multiplication of 1.9 times 3.7 is 7.3 mathematically. So you can just divide the 7.03 by the mass of P, and you'll get 2.4, which would be the velocity required of P to the left. So I put that it's to the left rather than say it's negative. And I think that's a very valid way of doing this question, and that will get you 3 marks. Okay, the mark scheme is on the next page, so I'll let you stop and have a look at it. All right, and they've shown you how they are giving the marks. 1 mark for understanding the equation of the conservation of momentum, yeah. 1 mark for rearranging the equation once you've worked it out, and 1 mark for getting the answer correct. And they're saying they're happy for you to ignore the sign in the final answer, but you saw the way I did it was to explain that to the left is the equivalent of negative. The next question is also related to this question, part C. It says a child drops an egg from a height of 10 centimeters and the egg lands on the floor. Explain why the egg is less likely to break if the floor is covered with a thick carpet than if the floor were covered in hard tiles. Okay? Well, the carpet increases the impact time. Basically, on both surfaces, this is extra clarification of why we're saying that. On both surfaces, the egg will lose all its momentum because it's going to come to a standstill. So the momentum will go to 0. But the rate of change of momentum, is reduced with the carpet. Because it's softer, it actually takes a bit more time, which is the bottom of this equation, for it to slow down, okay? And we call that the rate of change of momentum is reduced, okay? So that's a very good mathematical statement, but we've got to do it in English. So, because of that, the force is reduced. And the equation for force related to rate of change of momentum is F equals change in momentum. Delta means change in change of momentum over time taken. So whenever the time goes up, the force goes down. Okay? And this is actually Newton's second law. So I call it N2. This is Newton's second law of motion. And that's actually how Newton explained it. He didn't say F equals ma. He said it's related to the rate of change of momentum. And that's the end of the first question. Remember, if you find these videos useful, here's the mark scheme. I'll let you stop the video and have a look at it in case you've written it in a different way. So each of these points is 1 mark. The point of these videos is to show you the clarity that is required to get the full marks, the level of detail, and the key terminology, so your depth of understanding of the physics. You can't just write it in with everyday English. You've got to say things like, if the carpet reduces the rate of change of momentum. Yeah? You need to mention impact time. So you've got to learn the language of physics, and that's what reduces the force. Okay? So that's the mark scheme, and then you saw my solution in the question before. Question 2 is about moments, so we're going to go through moments, and that's the equation which defines moments, which is the first question and the first answer of the next question. So this is question 2 in this run through. So I'm going to stop the video there so you can have a look at it. So when you're watching these videos, if you find them useful, please like them and share them with your classmates if you're in a different school. I actually use these for my own students, and I find it very useful having them on YouTube, just so my students can go back and look over what we've been in class already. So we went through this today on a PDF, and I just upload the PDF with my voice over it. Okay, so this is for you to have a look at. So if you share it with your classmates, the more views we get, the more likely I am to add extra videos. So someone very kindly gave some positive feedback and was asking if I was going to do more difficult questions on these 3 topics. And I said this is coming because he looked at my first part, which was the non-triple content, so the double content, and he found my solutions useful. So he requested it. So if we get more views, if we get more subscribers, we're more likely to do GCSE solutions, or I am. There is no we, because the video was YouTube was originally started for my A-level students. Okay, because obviously they're more involved in terms of the questions that take more understanding. So, but I'm happy to do GCSE ones as well, as long as we get enough likes, shares, and subscribes. So in this question is about balancing moments. Okay, so clockwise and anti-clockwise. The diagram shows. The diagram shows a plank balanced horizontally on two supports A and B. So supports are A and B. So they're taking the load. And it says a block is suspended from the plank between the supports by a cable of negligible weight. So here's the cable, here's the block, and later on they tell us that it weighs 260 newtons. Okay. And they've said that we can ignore the weight of the plank, which in reality we shouldn't really, but they're just trying to simplify it because they know it's GCSE. In A level, you would need to include the weight of the plank as well. Okay. And that will be at the center of the length of the plank if it's a uniform thickness. It then says state the formula linking momentum, force, and perpendicular distance. Yeah. So momentum, I should write the word out in full here, equals force times the perpendicular distance from the pivot. Okay. Now the pivot is the place about which you decide to take the moments. Yeah. So it says in the next bit, by taking moments about A, support A, calculate force F. In other words, we don't know what force F is. They want us to work that out. Okay? And they've given us the distances from the weight W. I've called it W, the block weight. We need to use this as this is trying to go clockwise. And they've told us to take moments about support A. You can actually choose where you want to take moments about. And because they've told us to take it about A, all the distances must be measured to this dotted line. So for W is 25 centimeters, but we need to change that to meters to get the units correct. And force F, how far is force F from A? Well, it's 55 centimeters, which is 0.55 meters, plus 25 centimeters. So be careful. You're taking all the distances to the center of A. Okay? Once you know that, the green is a solution to the yellow question. All right? So you assume, again, they're reminding you, we assume the weight of the plank can be ignored. Is negligible means it's not worth considering mathematically. Okay? Now, that's the simplification. In fact, you do need to take into account, but in this GCSE question, they want to keep it with just two forces, F upwards, W downwards. So, W is turning it clockwise. So I call it CW. And F is going anti-clockwise, if you know which direction an old-fashioned clock rotates in. Okay? So anti-clockwise. Remember, the center of the moments is A. So we're rotating around A. Okay? So what you got to do, remember the distances are in meters. So this symbol means a sum of, sigma is a sum of. Clockwise moments for short, I put CWM, about A, because they told us to do it about A, must equal the sum of the anti-clockwise moments, again about A. All right? And if you always use the same point to take moments about, and they told us that the object is balanced, which they did in the beginning, you just multiply the force clockwise, which is W, 260 newtons, multiplied by its distance, which is 25 centimeters changed to meters, and then you multiply the unknown force, F, by its distance to A, which is 0.80 meters. So you basically, you know both the distances, you know one of the forces, but you don't know the other force. Okay? And you can just use your algebra then to make F the subject of the equation. And if you can follow the maths, 260 times 0.25 is 65, yeah? Divided by 0.8, which is the distance of F, and you'll get 81 newtons to two significant figures. And that's all you need to do, because that's the accuracy of the data we've been provided with. Okay? Hope that makes sense, and that will get you 3 marks. 1 for stating the principle of moments, which is the first line, yeah? 1's for putting the numbers in, and 1's for working out the answer. So just to show you the ticks, 1 mark, 2 marks, 3 marks. If you like, equation, numbers in, answer with units, as I always tell my students, but they've given you the units to be kind. All right. It then says, explain what will happen to the magnitude. Explain what will happen to the magnitude of F if the block W, I've called it, is moved towards support B. Okay? Now, obviously, if you move the W towards the right, its perpendicular distance from where we were taking moments, from A, increases. Yeah? Let's go back to green. So its perpendicular distance from A increases. So W's moment increases. Yeah? So because W is moving, it will increase the clockwise moments, yeah, about A. Remember, we're taking the moments about A. That's how I do it, okay? So, to balance that, to balance the moments, yeah, remember we've got to keep the sum of the clockwise moments. To keep the balance must be equal to the sum of the anti-clockwise moments about A. So, I'm going to put this bit in yellow. So F must increase. Okay? So I could put that last, really. Maybe I wrote it in the wrong way. So because you're increasing the distance of W from A, the clockwise moments increases. So I should have done it maybe. I should have maybe done it 1 first. 2, mentioning that the clockwise moments increases, and then 3, to keep the balance. That's what causes F to increase. So I kind of got 4 marks for these 3 marks. So I would definitely get the full marks by doing that. So the order in which I've written it is probably not the best, okay? But I kind of wrote it out first, and then when I spoke it, I realized you could do it more clearly. I apologize for that. So, my students, you can look at this and write it out again in your own words. All right. Question 3 is about static electricity. So, static electricity is from electricity. The photograph shows a person using a plastic wrapping to cover a plate of food. Okay? The plastic wrapping sticks to the plate, it says, due to electrostatic charges. Okay? The passage explains why the wrapping sticks to the plate. They're just telling you the passage as follows. They want you to use the words from the box to complete the passage. So one of my students said, I thought we were only allowed to use each word once. But then, if you read it carefully, each word may be used once, more than once, or not at all. So be careful when you're reading questions that you're reading it carefully. All right, so we got all the words in the box, and you've got to choose them, and they're testing to see if you understand static electricity. The person pulls a layer of plastic wrapping from the roll. Okay, that pulling produces some kind of friction. Forces between the layers of the wrapping transfer particles called, and you've got to choose the word electrons. Because only electrons can transfer because they're on the surface. Yeah? From one layer to another layer. Okay? So somehow one will gain electrons. And then it says, those gaining electrons, these particles, acquire a negative charge. So if you're gaining electrons, because electrons are negative, you're gaining negative charge. Okay? And the layer losing the electrons, because we're talking about the same particles, they just don't want to give it away. The one losing electrons becomes a positive charge. Same thing happens in chemistry in ionic bonding. Sodium will lose electrons and become positive, and say it's going to bond with chlorine. The chlorine atoms will gain electrons and become negative. Okay? So this is the essence of electricity, is the transfer of electrons. Alright, so then it says the negatively charged layer of wrapping repels electrons. If it's negative, it will repel electrons in the plate. So it's pushing the electrons in the plate away from it, leaving a positive charge on the surface of the plate where it touches the plastic wrapping. If you got excess electrons on an object, any electrons in its vicinity that are free to move will move away from the electrons on the other object. Okay? It then says the wrapping and the plate attract each other as a consequence. If it pushes the electrons away, there's a net positive charge left on the surface due to them having opposite charges. So if you got all five right, well done. 5 marks, and one of my students, or 2 of my students, managed to get all 5 right. Okay? Here's the words in the order that we should have put them. Question 4, and the final question, is about sound waves. So this exam covers the first 3 big topics of IGCSE. Question 4. A student uses this method to investigate the speed of sound in air. He sets up an oscilloscope to display and to detect and display a sound wave. So he then uses a computer and a speaker to produce a sound of known wavelength. Okay? The symbol for wavelength is lambda. You need to know that. He then uses the oscilloscope to determine the frequency of the sound wave. Well, you can't measure the frequency on an oscilloscope directly. You've got to measure the period of the wave and then use this equation to calculate the frequency. Once you know the frequency and we knew the wavelength, you can use the wave equation formula to calculate the speed of sound in air. So this is the wave equation. So that's the method. Okay. But one piece of equipment that they haven't mentioned, they want you to give the name of, the equipment that should be connected to the oscilloscope to detect the sound wave. And my students saw this, and the answer, of course, is a microphone. A microphone converts, and I spelt it wrong, I've missed out H. Have I? Yes, I think so. I'm now doubting myself. So, how do you do this question? So this, you need to know how to do this. It comes up very commonly in the paper 2 IGCSE exam almost every year. Okay? So the diagram shows the oscilloscope. Oh, I'm on the wrong setting. The diagram shows the oscilloscope screen and the oscilloscope settings. The oscilloscope settings are shown here in the key, and the Y direction is in millivolts, which we don't need for this part of the question, and the X direction shows the time base, and it shows that each square or each division is 0.5 milliseconds. So remember that milli milliseconds means 10 to the minus 3 seconds. You need to know your prefixes, okay? Now, we have, if you count the complete number of waves, and the complete number of waves is a peak and a trough, so that's a complete wave. Well, how many of those we got? 1, 2. Each time you get to this dot, you've gone to complete peak and trough. 3, 4, and one more peak, one more trough. 5 complete waves on the screen. 5 complete periods across 8 squares. So you got 5 periods of a wave, 5 waves, 8 squares. How much is each square worth? Tells you here, each square is worth 0.5 milliseconds. So if you got 5 waves, 8 squares, each square is 1.6 squares. And if once you, so you've got 1.6, you get 1 mark. And each square is worth 0.5 milliseconds, which is 0.5 times 10 to the minus 3. That gives you a second mark. So now you know that 1.6 squares worth is going to be 1.6 times 0.5 times 10 to the minus 3, which gives you the period. There it is, third mark. And then to work out the frequency, you've got to use the equation which I showed you before. And if you've got the standard form right, 1 over 8 times 10 to the minus 4 gives you a frequency to 3 significant figures of 1,250. Okay, and you should write that in that space. And they're giving you the unit to be kind. So was that a 4-mark question? So the final mark would be the answer. 4 marks, 1 mark there. Oh yes, here it is, 4 marks. Okay, so that's a very, very common question in paper 2 exams for IGCSE. No, I didn't spell microphone wrong. It's my brain that is telling me it was wrong. There it is. Okay, microphone. Let me see what I did. Oh, I spelt it right. So I apologize for my confusion. Microphone was correctly spelt. It still looks wrong to me when I'm reading it. Okay. So I apologize for my spelling. And then this is the mark scheme, the rest of it. So they're telling you that you need to know how to use the number of squares, for work out how to get 1 period. Best way is to use the full extent of the number of periods that you can see on the full screen, so it makes it more accurate. Whenever you use more data, it becomes more accurate. It's a way of averaging, if you like. Then understand that it was 0.5 milliseconds, so make sure you know that you've got to change the 0.5 to 0.5 times 10 to the minus 3, and then therefore work out the period correctly. If you get the power of 10 wrong, which is not realizing that milliseconds need to be converted, you will lose 1 mark. And then 1 mark for calculating the frequency. And that's what I showed you before. And this is their way of doing the maths. Okay. And then the next question is using the wave equation, speed equals frequency times wavelength, putting the numbers in. Well, we already worked out the frequency is 1,250 hertz. If you made a mistake, you could still use your incorrect value and still get marks for the next bit. Okay, it's called carrying your error forward. So You can allow your error, ECF means error carried forward, so they won't penalize you twice in this exam question. It's a 10-mark question, okay? And here is the next bit. So the wavelength of the sound wave that we knew was 27 centimeters. And they're tricking you to make sure that you know, to see which students know that you've got to change that to meters. Then they want you to calculate the speed using the wave equation and using your value for F from part 1, 1250. This in meters, 2 marks. Answer with units, 3 marks. If you put it like this, it would be 4 significant figures, yes, but you should really put it to 2 significant figures, okay? 340. Units given to you. Now then it says, describe how the oscilloscope could be adjusted to show fewer wave cycles on the screen. Okay, so the time base was set on 0.5 milliseconds. Yeah, that means every 0.5 milliseconds you'll see how many waves have passed through. Well, by changing the time base setting, you get 1 mark for saying that. So you've got to adjust the time base setting, and they're saying if you decrease the time base setting, yeah, that will show fewer waves. Decreasing the time base setting, what does that mean? So if you decrease the time base setting, so if you go from 0.5 milliseconds to say 0.1 milliseconds, that's decreasing it. So each square will be 0.1 millisecond, you won't be able to see the complete wave, yeah? So you'd have fewer waves on the screen. So in 0.1 milliseconds, so remember, this one, it took 5, so you were getting 5 waves on the screen, weren't you? Like that, you're getting 5 waves. If this was only 1 millisecond, you only get 1 wave in 0.1 milliseconds, okay? So you want to decrease the time-based setting, and if you do it by 5 times, you'll only see 1 wave. Hope that makes sense. That's the most difficult part of the question, and that's the final 2 marks for this run-through. I hope you found that useful. That's the end of the run-through, and if you did, please support the channel, support my channel, like it, each video you watch, share it, and subscribe so you can see when future videos are being made. So I'm kind of doing as many as I can in the build-up to the GCSEs, okay? So, and if you've got any comments or you've got any suggestions or requests, put them in the comments below the video, and I will try to do whatever I can to help you in your preparation for whichever exam you're doing. If you know students who are doing A-level, I do linear Edexcel as well as modular Edexcel, mostly modular, but I'm starting to do linear as well. So thanks for watching. Hopefully see you in the next video. Bye for now.